hardware, just like some game consoles maybe, or your phone. It can be little or big endian at will, so don't expect anything regarding the encoding at this stage. Try to reverse anything from big to little endian when you guess something longer than 1 byte. And look for fixed type instructions. Every relevant data for assembly level code should be aligned on 32 bits, except with the new opcode system, which is called ZAMP, and which supports 16-bit opcodes, which then may be aligned on 16 bits and not necessarily 32. MIPS is fairly similar to recognize. It's used in some workstations, just like the old SGI stations. It's found in some modems as well, and all the newest, no, not the newest, but fairly new game consoles. It can run 32 and 64-bit instructions. Once again, it's fixed size opcodes, which can be a waste because you don't want really one instruction to take 8 bytes, but just like ARM, it's packing instructions into one, but still it's aligned. And it can also run into little or big endian at will if you reboot it, so don't expect the endian to be always the same. PowerPC, now for the recent game consoles, and also your legacy Apple computers, X terminals. You can also play with such firmwares and look at how it looks like. Operating systems now. Besides the very famous ones like Linux or Windows, you may want to play around with Cisco iOS, or you may find into consumer markets some real-time operating systems, just like QNX or VxWorks, which I'm going to introduce now because they're not very well known for the regular, for the public. It's a Unix system which has a true microkernel design, which can be very interesting for the OS developers among you. You can also run it on your PC. You can download images and see what it looks like. And it's getting even more interesting now that Cisco is using it for their new operating system on their newest high availability routers. It's actually running QNX even if it's set iOS. VxWorks is fairly similar to QNX, another real-time operating system. It's used into some space stations, even space satellites, not like your Sputnik thingy, but real satellites. And in your regular hardware, if you have a Linksys WRT, it may run under VxWorks instead of Linux, depending on the revision you have. Some DVD recorders use it as well, some digital cameras, modems, and even some printers. Some printers actually run full-time, real-time, full-featured Unix operating systems such as VxWorks. So just have a look at anything. It can run an operating system with a complete TCP stack and make some noise on the network. Now, if at this stage we are still stuck because the vendor did a really good job or it's ciphered in a way and not just compressed or twisted, we can consider ciphering and deciphering. By definition, encrypted content is looking random for the eyes. Not even strings can tell you anything about it. But again, we may have some clues somewhere about it because as the rest is designed by humans, humans make mistakes. Perfection is really difficult to achieve. And as such, every algorithm may reveal some signatures or patterns when you look at it in a different way. It's not my specialty, but I know that there is encryption and encryption. And if you look at embedded hardware, you may not have as much power available as for your new Core Duo laptops. So don't expect the crypto level to be too high. It can be, but it's worth a try. So if it's not just a pure algorithm, just like XOR, try it. And if it is, it's certainly unpacked at boot time And so the logic is there, just written in assembly language. So try to reverse it. Try to reverse just the bootloader, or what looks like the bootloader. If there is a key, it's certainly there in the clear. Unless with the newest DRM devices, but I don't know if there are so many here, and some implementations are just broken or not using them. If you want, however, to have a look inside the hardware, you can do it also, but you can expect to have to save almost €1 million to get a microscope powerful enough. But anyway, you can get some cryptography books, or actually ask Dan Kaminsky. He's been doing some work recently about how to draw pictures from data, any kind of pictures. He's doing some very nice abstract paintings, and seriously, it helps. We can imagine recognizing, for instance, the same image encoded in GIF or JPEG instantly, and then recognize other images encrypted in GIF, opposite to next to JPEG versions. Because the patterns, if you draw it in a good way, will just stay coherent for GIF images and JPEG images. So if you can determine patterns for, say, a or blowfish or serpent or whatever, maybe you can guess how it is actually encrypted. Of course, you don't have the key yet, but still, it helps. What is this penguin doing here? Okay. We'll have a look at encryption and encryption, actually, because there are two main ways of doing it, by cipher chain blocks or purely block cipher. Let me explain. In the first case, the key is the same as in the second case, but the data is not randomized by or influenced by the previous block, which means that for given input data, the encrypted data is always the same. So even if it doesn't look like a penguin, unless you look very closely, you can see it. You can guess that it's a penguin in steganography or encrypted in a way. And you can apply the same principle for regular data. If you recognize patterns and it looks like, for instance, a fat record, but it doesn't correspond to a fat record, try to modify it, correlate, graph it, and see if it can not exactly be a fat record from with an encryption in any way. And now for the last part, we will tell a bit about disassembly and how to emulate the images we just uncovered, and why not debug them. Disassembly software, I would recommend using NISM for x86 or the GNU binutils for the rest. And for Windows platforms, you may know about ODDBug and IDA Pro already. IDA can not just disassemble Windows executables, but also all kinds of architectures and operating systems. It's not free, though. And there are rumors that it may be removed from the market sometime soon. Now, emulation. It's getting really looked at currently. I see every day new announcements of new emulation software available. And you can already emulate pretty much everything that has a processor, a memory, and a process counter, actually. So for x86, you have lots of different choices. I'm going to explain just after this slide differences between the two major ones. PAPC for PowerPC. MIPS has a high number of emulators available. You can also play games if you want. You certainly know MAME. And there's also a number of emulators for Cisco routers. And I'm running out of space, but there's really plenty. So Box, free software and designed for operating system developers. which means it can also be useful for us because it works with GDB. So you can actually get stack traces and get some runtime information whenever you want. Fetch runtime memory emojis. It includes also, on top of that, its own debugging system. And it's going to tell you if the current instruction running is looking like an actual word or not, depending on the status of the registers or the processor flags or anything. On the other hand, QEMU can run in native mode faster, but you cannot analyze just as much because it actually, I think it vectorizes instructions. It creates instructions from the original image and directly runs it in memory. So you cannot really hook into it unless if you run into the other mode, which it also supports. And not like Box, it also supports Spark, ARM, and MIPS architectures. So it can be very useful to emulate, debug, and analyze firmware images besides x86. And it also works with GDB now. No, I'm almost finished, sorry, with this talk. Wikipedia was a very good help with this research. I think you know how to use the search button on Wikipedia. There's articles on pretty much everything already. The NetBSD page about emulating the ports is really complete about how to run software from any processor available, something like 30 or 35 different architectures. You also want to fetch the assembly reference books and why not the specifications parts of your user's manuals for the hardware you're currently looking at. Look for any clue, use Google, use Wikipedia. And I thank you for your attention. I thank also my company for giving me some spare time to do this. Check out our website. I just released my tool yesterday. It's not complete. It's not as, it doesn't go as far as I wanted yet. But if you want to contribute, you're welcome. Just drop me a mail. Stay tuned. And if you have any questions, just ask anytime. Thank you.